I'm going to explain the first week problem set of Mac 217. So we have the problem of company revenue function and the cost revenue function of company. So we are going to find both the companies of me, like we are going to find out the curves and the quality, calculate this quantity. So the first we need to find out the derivative of the both functions, r of x and c of x. Once we derivate, we got the values of r of x, negative 0.06 x plus 750, and the derivative of cost function, we got the value of 0.0006 x square minus 0.04 x plus 400. We got the both values. Once we got the both values, we are going to substitute the 0, we are going to substitute the values in x and like 0 or 1 like that. So once you substitute those values, you will get the x value. We got this revenue cost of cost value and the cost revenue function and the cost function. Once we got the both values, we are going to graph the we are going to plot the graph, and we are going to draw the graph curves. Once you plot the both curves, we are going to find out the intersection of the both. We are going to find the area between the two curves. We need to find the point of intersection, so but the further we need to use the formula of x equal to minus like negative b plus or minus under root square b square minus 4ac by 2a. So by using that formula, we are going to find out the x value. Since the square root of the negative number is not a real number, we know that. So once we got the not a real number, so it will be the curves are not going to be intersect. We can conclude that there is no real solution for x. So we are going to find the area between two curves is defined as the difference between the definite integral of the f of x and the definite integral of other function, say g of x, with lower and upper bounds as a and b respectively. So now I would like to explain the second problem of this weak problem weak problem set. So the second problem, we have to find out the value of c in the given problem. So we need to find the point of symmetry of f of x, because it is the point of which is the point at which the graph function is reflected across the x-axis. To find the point of the symmetry, first we need to find the first derivative of the f of x to equal it to 0. So we need to derive it, and we have to equal it to 0. So we need to derive. Once we got, by simplifying, we got minus 81 x square plus 8 equal to 0. We get the x equal to plus or minus under square root of 8 by 81 81. So after simplifying it, we'll say the final value of the plus and minus under square root 2 by 9, 2 by 9. Now we know that the point of symmetry also value of x, which is the area of above y equal to c, the given because we have the given the condition, we have given the question as well. And our f of x is the equal to the area of under both y equal to c and f of x. To find c, by substituting x value, we got the x value, right? So x equal to square root of 2 by 2 under 2 divided by 9 in the given f of x. So once you substitute, we will got the c value, the given we can see that in the c equal to 8 under root 2 by 9 minus 6. So this is the problem. We are going to conclude this problem by find out the c value. So now I would like to discuss about the problem 3. If we have the problem 3, we have the initial amount of money. The problem 3, it is going to ask if an initial amount of a naught of money is invested of an interest rate at are compounded n times a year, the value of the investment after t years. So the given equation, like a equal to a naught of 1 place r divided by n square root, like power to the of n to t n to the power of n t. So if n extends to infinity, we refer to the continuous compounding of interest. Use the hospital rule for to show that interest compound continuously. Then the amount of t years is t years could be in the a equal to a naught e to the power of rt. So we are going to find by using the L hospital rule. We are going to find this problem by using L hospital rule. we show that we are show that the if interest is compounded continuously, then amount of after ts is a equal to a naught to the power of e to the power of rt. Let's consider the amount of money after ts with discrete compounding. So the formula we that formula we have that a equal to n to the power of 1 plus r divided by n to the power of n to the power of nt. So n extends to a infinity, the number of times the interest is compounded in a year becomes more and more frequent. Results continuous compounding. To find the limit of a as a n infinity n limits to n instead to infinity by using the hospital rule, limits n is infinity n in instance to infinity equal to n infinity n limits to a infinity, a naught by a naught of 1 plus r by n by using this formula. So we are going to use this formula and we are taking to derivative of with respect of to on the both numerator and denominators. So we are going to going to derive with both numerator and denominator values, and once you do once we get the value of this value like this is the value of d of 1. We got the value of d by dx of the first numerator value. We are going to derive it, and the denominator d of dx by 1 equal to, like we know the derivative of 1 equal to 0, we know that. So once we derived that value as in n approach the infinity, the term of the term of 1 plus r by n into the n to minus 1 approach the e to the power rt, and the minus r by n approach to 0. So that limit of a approaches as infinity becomes limit n limit n instead and extends to infinity, a equal to a naught t e to the power of rt. Here's that amount of money after 70 years, like with continuous compounding, a equal to a to the power of a not e to the power of rt. As n extends to infinity, the amount of money after t years with discrete compounding reaches the amount of money after t years after the continuous compounding. So I think I given explanation of all three questions. I'm not sure, like this is my first video of making the recording of the explanation of questions. I think I little bit I did little bit confused, like question like I'm not little bit clear. So if you not get correct explanation of this question, so we can you can just intimate me before score grading these questions, and I will upload new record of these videos questions, and I will happy. Thank you for this.